Hello, everybody, and thank you so much for joining our webinar today with WatchGuard and Cylance and, of course, WatchGuard. This webinar is called Delivering Predictive Protection with Artificial Intelligence. My name is Christine Ramsdell, Marketing Specialist here at WatchGuard. I'm also joined by two presenters, Mark LaLiberte, Senior Security Analyst over at WatchGuard, and Sarah Lofgren, the Channel Sales Engineering Manager at Cylance BlackBerry. So before we begin, I want to go over a few housekeeping items. The first is that the audio streams through your computer only, so there is no dial-in. Next, all the widgets on your menu are resizable and movable. Third, there is a Q&A box on your widget menu, which will be answered at the end. But at any time, please feel free to enter your questions into the box. The on-demand recording of this will be available as the same live link as you used to enter this webinar. And lastly, we do offer CPE credit for our webinars. This webinar is for an hour and therefore will be 1 credit. Please check in with your certification body for more details. And without further ado, I'm going to pass it off to Mark to introduce himself. So Mark, take it away.
Perfect. Thank you, Christine. So as Christine mentioned, I'm a senior security analyst at WatchGuard Technologies. I've actually been here for quite some time now in a few different roles and responsibilities, but right now I manage our threat research lab, what we call the WatchGuard Threat Lab, where we have a team of researchers that every day takes the threat intelligence we receive from our Firebox appliances deployed throughout the world, and then puts together reports and actionable defensive tips for all of our customers and other people in the industry. Even though I'm technically a manager, you will never see manager in my title because as soon as you put that in there, you lose all of your street cred. So with that, I will hand it off to Sarah here.
Thank you, Mark. Speaking of losing street cred, I'm the Channel Sales Engineering Manager. I am also technical. I came from Channel Sales Engineering. I've been with Cylance for almost 3 years, which in startup years feels like 300. We were recently acquired by BlackBerry, so we're now BlackBerry Cylance. So Cylance was founded in 2012 with a focus on using big data and artificial intelligence to solve real-world problems. Specifically, security is where we started. And I have a passion about this technology and innovating security as a whole. And then BlackBerry, with their acquisition, is a perfect union of focus on mobility, the Internet of Things, the larger endpoint security problem, meshed with what we've already done with artificial intelligence on your workstations and servers. So excited to be here and looking forward to seeing what kind of questions you guys have. Back to you. Thanks.
Awesome. So for our agenda today, we're going to start with just an overview of artificial intelligence and how it is applied in security. And then we'll talk about the delivery of the predictive protection, which is what Cylance's product built into WatchGuard is able to deliver to help protect against what we call zero-day malware threats. Part of this will be Sarah talking about the predictive advantage and how we train the AI models in order to detect threats before we even realize that they are threats. And at the very end, we've got a short demo showing how this technology can help protect against a ransomware payload that I found just a few days ago. So to start out with, let's go ahead and jump into what exactly we mean by AI and artificial intelligence. Because if you're like me and you go to security conferences throughout the year, you're probably sick of seeing AI show up on the buzzword bingo board. So when it comes to AI, we're talking about the capability of a machine to exhibit intelligent human behavior. And that can mean a lot of different things. Your smart assistant like Alexa or Siri or Google Home can count as artificial intelligence. If you watch the episode of Jeopardy where Watson took down some very intelligent folks on it, that's another application of intelligent artificial intelligence. IBM Deep Blue, the precursor to Watson, that took down a chess champion, was also an application of artificial intelligence. Another subset of AI, though, is something called machine learning, which is an application of AI that allows a computer program to automatically learn and improve from experience without explicit programming. And what we mean by this is almost all smart devices, first off, use machine learning to improve different things about them. In the background, Amazon Alexa uses machine learning to understand voice commands and how to respond to different conversations. IBM Deep Blue used machine learning to understand chess moves. Really, machine learning has uses, though, outside of programs that interact with humans. We can use machine learning to classify images, for example, with facial recognition, where given any image, we can predict the name of the person that owns that face. With Intelligent AV and BlackBerry Cylance's product, we can also predict whether a file is malicious or not, given the contents of that file. And just like how humans learn from experience, so does artificial intelligence. In different computer program, this is really different from a traditional computer program where something that I just write without machine learning or AI can't adapt. We can create software to look for very specific things, though, and it still does a decent job of catching those very specific things. Like I could create a program that looks for a piece of malware that starts using Windows encryption libraries. And we look for malware that maybe saves data on the disk with 64 kilobytes or more somewhere. But what happens if the malware evolves and starts having different characteristics? Maybe it rolls its own encryption, or maybe it saves data in a different location. These programs that we teach to do one specific thing will start to fail at that point in time. And that's where machine learning comes in, where if we have a piece of software or a service that runs with machine learning and AI, it can learn to identify these trends that a normal human might not notice and might not consider relevant. And then it uses these features from its previous learnings to predict if a piece of software or a payload is malicious or not. Now, one of the biggest failures when it comes to traditional anti-malware services is that they're all signature-based, and they rely on a human analysis in order to create or at least confirm these signatures. And this isn't real time. Really, these updates only happen a few times a day, which means when a new piece of malware comes out or a new way to obfuscate malware comes out, there's going to be a patient zero that we call them that gets hit. And in reality, there's going to be many patient zeros before a signature becomes available to protect against that specific threat. And if that threat morphs in any way at all, it'll bypass those signatures and continue to hit people until more additional signatures can be developed. You can see where this starts to become a problem. And by definition, signature-based anti-malware protections cannot catch this zero-day malware. And it really has a problem catching even modified known malware, as you'll see in the demo in just a little bit. And one of the benefits of AI and machine learning is that computers are really great at analyzing these large data sets, so large amounts of malware and benign computer programs out there, and then formulating their own decisions on whether or not some unknown piece of software is malicious or not. So one of the things that we in the WatchGuard Threat Lab track every single quarter in our internet security reports is this thing that we call the zero-day malware number. And this is different from a zero-day vulnerability, which is a vulnerability that is unpatched. This is zero-day malware, meaning malware that can get past traditional signature-based antivirus and anti-malware software. That could be a brand new piece of malware, or it could be something old, even decades old, that's just uses tools like packing and crypting in order to bypass signatures that were developed for it. So far through 2019, that zero-day malware number has been hovering right around 32%. So in general, if you are relying on signature-based anti-malware protections, you're missing 1/3 of all threats that are coming into your network, which is a huge amount of malware to be missing. And we've seen this fluctuate as high as 40-45% in some quarters as well. So it gets really bad if you're just relying on services that use signatures in order to detect these threats. And I think this quote does a really good job of explaining one of the biggest problems with traditional anti-malware engines. It says, in the time between detection of attack and application of the corresponding updates, systems are vulnerable to compromise. And almost by definition, at least one victim, the so-called patient zero, has to experience the threat before new protection systems can be deployed. And this really highlights that in order to create a signature, we have to see some malicious behavior or see the process, the application, the file itself in order to develop protections for it, which means someone has to get hit by it. And then we still have to deliver that signature in some way to whatever engine is running to try and detect these threats. And that takes time as well. So really, it is much more than at least one victim, and usually quite a bit more, before a signature can protect against that specific threat. And one of the big issues you'll see is that SMBs specifically lack both the headcount and the expertise when it comes to security. And the team is often operating in blended roles with people that might not even be security experts or technology experts. Sometimes it's just the most tech-savvy person in the room that's in charge of setting up these systems. And they're wearing many different hats and have different responsibilities. Automation of security process is really a time saver that allows IT to spend more time on business-critical tasks. And AI is able to make sense of huge volumes of data, like I mentioned, and it's a process that would normally require a very skilled security analyst to complete. And SIMs, you've probably heard of SIMs before. They're great security management tools, but some of them are really out of the reach for SMBs that operate on really tight budgets. And even if you have a SIM, the data's there, but there's time constraints, which mean that it's much more difficult for SMBs to analyze this data and correlate threats and consume them in a way that's useful for their business. AI can perform all of this correlation and analysis and scoring for you, and it learns from multiple threat intelligence sources to ensure that your systems are safe from these attacks. And automated remediation also helps by minimizing the disruption for your businesses and allows them to refocus their IT teams on the tasks that matter most to you. Now, malware threats appear and spread globally in the blink of an eye. So AI provides an intelligent layer of defense able to detect and defend this malware much earlier than these traditional legacy approaches that we've been relying on in the past. And once properly trained, AI is able to offer predictive protections that anticipate future attacks without needing signatures at all, or even cloud connectivity. It's all built into the engine with periodic training updates, and it can inspect any payload and make a decision right then and there if it thinks it's malicious or not and act on it. And AI is able to look at hundreds of thousands of different characteristics that a normal human, even a highly trained analyst, might not even realize is important for that type of malware or that type of attack. And it can use these different characteristics to really rapidly come to a determination on that file of whether it's malicious or not. So with that, I will hand it off to Sarah to talk about how AI is actually trained using BlackBerry Cylance's model.
Thanks, Mark. So we'll talk a little bit about machine learning here for a minute. As Mark had mentioned, there's a lot of different applications for machine learning. We talked about Amazon shopping prediction or Netflix. This is the type of movie you might like to watch. And those are all elements that are trained by the user. So they're pretty simplistic, pretty early generation machine learning applications. And if you go back earlier on, we look at something like a spam assassin type technology where you're training by marking your files or emails rather as spam or good emails. And it works to an extent. But the problem with those types of uses is that they really are only as good as the data set and the user that's training them. So the big challenge with using machine learning well and using it in a way that is going to be highly accurate and predictive is that you need to start with a very large data set, and the information that you're training on needs to be very accurate. So what we did as a company is we used elastic cloud computing to build a corpus of binaries, executables, both good and bad. And actually, it turns out it's really easy to find a lot of bad files and a lot of good files that are already tagged accurately for you. So we put those in the cloud, and we started looking at what we could do statically. And when I say statically, I mean disassembling a file without running it. So our researchers started by looking at a few hundred to a few thousand things. If all of the researchers out there were asked, what can you look at on a binary to determine if it's good or bad? So we had those billions of files that were tagged as good and bad. So we looked for those features, and then we sent the AI or the machine learning algorithms after all of that data and started processing it. So what we were looking for is features in those binaries. So what we came back with, the AI came back with millions of things to look at. Some of them were relevant and some of them were not. And so as our data scientists began to tune these things, we would start to classify and cluster those features. So let's say, for example, we saw a pattern in a specific set of files that we knew were ransomware. Did we see that pattern across lots of different families of ransomware? Perhaps. Did we see those features in good files? No, we didn't. So that starts to give us information on what features are relevant and not relevant. So we cluster that data together, and we continue to refine and enhance what we're looking at until we end up with a math model that's built by the AI, and we can use that to run against files. So we take the algorithm and we run files that we haven't looked at before and see how it does on scoring them, and that can give us an accuracy level on that. So the end result is a math model that is it's really elegant. It is lightweight, it is portable, and because it uses math, it's really fast and accurate. But it's also predictive because we don't need to have seen the malware before. We just need to have seen a particular feature set in a piece of malware to recognize that that feature is indicative that what we're looking at now is also bad. So let's look at how that actually works. So if I take a binary and I say binary, I mean executable, it could be a DLL, or potentially Office documents. If I'm looking at that and disassembling it statically, that algorithm is going to look at things that a malware researcher would look at. File header information, could be string data, could be the packing or entropy in the file, certificate data. But the thing is that, as I mentioned, we're looking at millions of features or combinations of features because machine learning is looking at things that a human can't and processing these zeros and ones, this assembly code, in a way that a human can't, and has looked at many billions of binaries. There's going to be things that we're detecting in the files that are good indicators that we wouldn't necessarily recognize as a human at all. So we get this lightweight algorithm, and now we can put this into a solution like WatchGuard to look at these files as they're in your environment. And the great thing is, as I said, it's static, so we don't need to run it, and we can recognize right away that it's good or bad. And the algorithm is a sort of, it's a predictive technology, but it's something that doesn't need to be updated regularly. So there's no updates, chasing down your environment, patching it, crossing your fingers that you're not going to cause blue screens or break your technology or break your firewall, because that is a static algorithm that only needs to be updated in a very rare instance. So let's talk a little bit about what the predictive advantage really means for you. So SC Labs was kind enough to do some independent testing on the algorithms and how this works in your environment. What they did is they took models that we had released, and we have multiple generations of models. We release new models only when they're statistically significantly better at detecting malware and better at identifying good files. So we took these models and we had the date they were released, and then we threw malware at them that was released after the date of our model. And we looked how many months in the past the model was released versus when the malware was first seen in the wild. So you can see Petya, non-Petya, WannaCry, if you remember all of these outbreaks. And the same still applies with Emotet and whatever new 0 days may have come out this year, as Mark was talking about, close to 30%, I think, was the number that they had. And we're highly successful at predicting things months or even years in advance with these algorithms. So that means 0 days that haven't even been written yet, because of what we look at in the files, will be caught by this technology. So you're protected without waiting for patient zero or for signatures to be written. So as SE Lab said, not only does the data demonstrate that our technology was capable of preventing threats that did not exist, but it provided insight into how far in time it could be effective without new knowledge. So we don't know how far in time yet, obviously, because time keeps marching on, and we don't know what's been written. But we still see 99% plus effectiveness on our algorithms years in the future. So not that we won't release new models, but even as we're in between models, you'll continue to have that zero-day protection. And that just speaks to the predictive power of looking at data sets using machine learning and producing an algorithm. What this means, though, is for all industries, whether you're in financial or insurance or medical or manufacturing, whether you're SMB or larger, it doesn't matter. The problems are still there across all verticals, but you can save yourself from those business halting incidents where malware takes down your network. If you remember WannaCry, there were some very large companies that were impacted, but also a lot of small ones. And without security operations to remediate threats and to disconnect machines and halt that outbreak, many companies were impacted or are continuously impacted by these campaigns without recourse. With a predictive algorithm, that issue kind of goes away. I'm not saying we're perfect, but the application of the technology is, it's just really compelling. So I'm going to hand it back to you now, Mark.
Perfect. And I think Sarah just brought up a really good point in that these days I go to a lot of conferences and I talk to a lot of IT folk that work at SMBs and a lot of non-technical folk that work at SMBs as well. And a disturbing trend that keeps coming up is people go, oh, well, I'm not a target. Why would anyone come after me? I'm just a small, whatever, 2-person, 3-person, 2 dozen, 3 dozen shop. The problem is that a lot of these malware continues to evolve. And as these threats get more and more serious, they can still blanket carpet bomb even the smallest organization. So just because you don't have the bank account of a Fortune 500 company or the intellectual property valued as high as them as well, doesn't mean you aren't a massive target for these types of attacks. Things like WannaCry are indiscriminate, and they'll just go after anyone that has that specific vulnerability that it's going to try and exploit. And that's why you need these tools that are for enterprises brought down to your business as well. Now, I've done a lot of bashing on traditional signature-based anti-malware services throughout this presentation, but they do still have at least somewhat of a place. They're good at catching the bread and butter malware threats that we see every single day quickly and very, very efficiently. But they are not perfect, and they still let a lot of threats through. Now, you saw earlier that percentage was right now right around 33%, or 1/3 of all malware can get past these traditional signature-based anti-malware engines. And that's why at WatchGuard, we always preach what we call a layered approach to security, where you still use these tools that may not be 100% effective, but they're really good at what they do. So even a basic firewall, just shutting down ports, can help protect you against a lot of these network-based vulnerabilities that different malware and threats try and exploit. The intrusion prevention systems can help stop and detect these attempted exploitations of threats. Signature-based anti-malware can catch the real bread and butter threats that are still going out there every single day. But then on top of that, you need more advanced tools in order to catch the more sophisticated attacks that continue to hit small and medium businesses every single day. And one of those tools that we just recently added was BlackBerry Cylance's engine into our products in what we call Intelligent AV, which takes their full model, their full predictive model, and allows us to now predict threats and correctly mark them as malicious, even without signatures or without having seen them before. And behind that, we still have APT Blocker, which is our cloud-based sandboxing solution, which is the final line of if the most sophisticated attack makes it through all these different layers, you still have something left in place to try and catch it. And then behind that, on the endpoint, we still have TDR, our threat detection and response agent, able to detect and analyze suspicious activity on the hosts that maybe it didn't even come through your perimeter and came through some USB stick that an employee brought in or what have you. This should highlight the importance of having multiple layers of protection because there is no silver bullet. Like Sarah mentioned, BlackBerry Cylance does an amazing job, but we will never say that we're perfect at stopping every single threat with one single service. And that's why you need layers of defenses there to catch everything. So now I've got a quick demo to show you how Intelligent AV can catch a masked ransomware payload that I found just a few days ago. And the demo runs a bit quick, and I'll try and narrate over it in order to explain exactly what's going on throughout it. So let's go ahead and roll in here with the clip. So we start with one of the quickest or easiest ways for malware to get into our networks, and that is a phishing attack. So our unsuspecting victim will go to phishing.site and see their file download is ready. They'll click it, and even though it has a very obvious name of ransomware, they'll still run it anyway because our end users aren't always the best. You'll see this ransomware works really quickly, and we can pull up the ransom note, and as soon as you see this, you know that you're going to have a really bad day. Luckily, through the power of VMs, we're able to go in here and revert back to a safe space so we can run the demo again. So that was just a ransomware payload going through with no protection enabled on the network or the host itself. Now we're going to turn on the HTTP proxy on the firebox in front of the system, and then we're actually going to go in and disable Intelligent AV right now. So right now, the only thing protecting this host is the signature-based gateway antivirus. And remember, this ransomware payload is a few days old now, so we do actually have a signature for it, which you'll see here when we go back to the phishing site and load up the malware again. Gateway antivirus will detect it and block it. If you can't see the text, it says failed network connection. If we go into the logs and you can see through the artifacts here, you'll see a deny message for detecting a virus with a generic ransomware signature, one of the ones that we added just in the last few days or so. So now I'm going to hop onto my Kali Linux install and use a program called Amber, which is an open source packer that anyone can use to hide malware easily from signatures. Runs really quick. I've now masked that ransomware payload. And if I hop back on that same host now and try and download it again, you'll see that just with that quick little change there, using an open source program, I can now get past signature-based anti-malware. And if I run that payload again, you'll see very quickly here that it encrypts all of my files, and we're back to having a really bad day again. And that was how easy it is for the bad guys to get past signature-based anti-malware, even with a payload that we would normally have a signature for. So I'll revert back the snapshot here, hop back in and enable Intelligent AV, which will then now be able to detect that packed payload. So it's the same malware that made it past signature-based antivirus with just a packer, and Intelligent AV now will run it through its model, notify the different features that, or notice the different features that mark it as malicious, and you'll see it blocks it right away. If we hop back in the logs, on the firebox, you'll see we've identified it as a virus again. In the case of Intelligent AV, we just label it as malicious because the model can't tell us exactly what strain of attack this is. We just know it's bad and we know we want to protect you for it, and so we block it. So that was pretty quick, but I think it showed really well how gateway antivirus has a use. It can detect an old threat, something a few days old, but it's so easy for attackers these days to go in and modify these attacks, even on a target-by-target basis, to make them bypass signature-based antivirus. And that's why you need these other layers of protection, especially tools like Intelligent AV, which is powered by BlackBerry Cylance, to predict whether this payload is bad or not and block it. So I think we've saved plenty of time for Q&A. And with that, we can open it up. And Christine, you want to handle pitching those off to us? It looks like we have quite a few questions in here.
Yes, of course. So thank you, everyone. So the first question here is there an integration between Cylance and WatchGuard products?
Yep, I will take that. So that is that intelligent AV service that I just mentioned. It comes with the total security subscription. So if you already have TSS for your Firebox, you have access to intelligent AV. The one caveat to that is that intelligent AV does not currently run on our tabletop appliances, our current generation of tabletop appliances. So your rack mount ones, you'll be able to get it. The tabletop ones, we weren't able to squeeze the engine in there with the limited resources we had. The good news is our next refreshes of those should have access to it. Christine?
Perfect. Thank you for that, Mark. So the other question here is, let's see here. Okay. 1 minute. Here we go. All right. So, for example, I have a WatchGuard M470 at my primary location and T35 at a remote location, for example. I also have Cylance Protect on my endpoints. Does this mean I'm slowing things down by duplicating the Cylance layer?
No, it does not. Not at all. These engines work really quickly at identifying a threat. And so in terms of the Firebox, it's just another millisecond, basically, of computing power dedicated to it. We're already scanning any file that goes through the Firebox once you have antivirus enabled. And it's just one more little cycle to go through, run it through the model and see if it's bad or not. And I think that's actually a really good idea because it shows that layered approach. You really do need these multiple layers, both on the network perimeter and on the hosts themselves, in order to catch the more sophisticated of threats.
Got it. Thank you, Mark. And I know that you mentioned this, but can you define tabletop that you mentioned earlier?
Yes. Specific model numbers, anything that starts with a T is one of our tabletop models, whereas anything that starts with an M would be one of our rack-mounted ones. And I think it's the M270 and higher right now that supports intelligent AV, and obviously anything going forward. Just not some of our legacy older rack mounts that might still at least be in support, and none of the older tabletops.
Got it. Thank you. And so, for example, if we have a WatchGuard subscription that doesn't have intelligent AV enabled, despite buying the full total security suite, how can I add that to my subscription?
Sure. So it should be included in total security. You'll just need to update your feature key in the web UI. Under your feature key management, there's a little box just to sync it with our servers. And so long as it's a supported model, so M270 or higher, you'll now have access to that checkbox is really all it is under your security services configurations. And you just have to go into Intelligence AV, click a little checkbox, and you will be good to go from then on out. Very simple to configure.
Got it. Thank you. And then this might be a question for Sarah or Mark. So can Cylance perform its function on HTTPS traffic?
I'll go ahead and take this. So through the Firebox, we have the ability to decrypt HTTPS traffic. Using the HTTPS proxy, we basically do a man-in-the-middle connection on that network traffic going through the box, which allows us to view it all in an unencrypted state. It takes a bit of work to set up. You'll need your own certificate authority locally. If you've got Microsoft Active Directory already, good news is you're already 3/4 of the way there. But once you set up that HTTPS inspection, we can view it in the clear and run everything straight through that model just like you would with unencrypted traffic, which is really important because a lot of the attackers these days are using encrypted channels to deliver their malware because it's so easy these days to get a certificate to encrypt anything coming to and coming from and going to your web server.
Perfect, thank you. And then it looks like is Intelligent AV going to be available as an update to a desktop model, or is this more of a hardware factor?
It's more of a hardware factor. A lot of the tabletops and I think that M200 and 300 before the refresh were really light on resources available in terms of RAM. And we try and cram as much security services as we can in there without impacting usability or network throughput at all. And it was just the trade-off of adding this new service was the one last one that would have ticked it over the edge. And so it's on some of those older boxes, we don't have intelligent AV, but going forward, just about everything should. And I think I see one question in here about Firebox V as well. It should be available on there. You just have to make sure you allocated enough resources. In our tech docs, I think we recommend like 4 gigabytes of memory for your Firebox V installation.
Great, thank you. And then will intelligent AV ever be offered on M200, 300 boxes?
I don't think there are plans for that. Just the refreshes, so the 270, 370.
Got it. Okay. And then when are the next refresh of T-Series coming?
That is not something that I actually know the answer to. We'd have to chat with product management on that one. And I'm not sure I'd be allowed to even share it if I did.
Great. Thank you for that. And so is there any way for WatchGuard to handle PIN certificates?
So I think with that, they're talking about like standalone desktop applications like the Dropbox application that don't use the certificate store built into like Windows or your browser, and instead have their own CA certificate that is the specific one they're looking for in the application itself. And in that case, there really isn't anything that we or anyone else can do about that. As soon as we try and man in the middle of the connection, we have to re-sign the connection with our own certificate in order to deliver it encrypted down to the client after we're done inspecting it. And if that client is expecting it to be signed by one specific certificate, there's no way that Dropbox is going to give us access to their CA, which means there's no way that we can man in the middle of that connection, unfortunately. That's just one of the limitations of HTTPS inspection in an office environment in general. The good news is those cases are few and far between. There's a few applications that do it, but most of these software companies recognize that companies want to be able to have insight into the traffic that's going into and out of their networks to protect it. And so within these standards, there are ways to allow that to happen without compromising security for the rest of the world, basically.
Can I just jump in and add to that?
Yes, please.
Yeah, so in the instances where the bad file does reach the endpoint, this is where we go back to the security and layers piece, where you're going to be eventually executing that file, the math models, if you have silenced endpoint agent, then we would be able to analyze the file while holding the execution and then quarantine it once it left the application, however you may have downloaded it. So this is where it is a critical application security on the endpoint, as well as having your network security and your security and layers. It's all part of the stack and part of the larger picture of protecting your data wherever it may be.
Exactly.
Got it. Thank you both here. And then, Mark, which services does Intelligent AV work on?
So Intelligent AV requires a proxy because we need to inspect the application traffic itself, which means right now it just runs on, I think it's HTTP, HTTPS, our FTP proxy, I believe, is in there as well, and then our email proxies too. So it won't work on packet filter policies. Basically anything we have a proxy on. I don't think it works on the VoIP proxy because most people don't transfer files over VoIP.
Got it. Thank you, Mark. And from your demo that you had earlier, it looks like it wasn't running the file. So can it do anything with the encrypted files?
So in the demo I ran earlier, there were a few different scenarios. The first one was no protection, which the file just came in and executed. And then there was one where Gateway Antivirus detected the old original payload. You'll still see the file download like window pop up, but the download itself is interrupted. I think Firefox or Chrome is what I was using. It'll say like a network error interruption, and that's us blocking that file from actually reaching the endpoint. It knows it's supposed to expect a file, but it doesn't actually get it, which is why it throws that error. With Intelligent AV on the packed obfuscated file, it's the same deal. Your end user will see that their browser tried to download something, or maybe they tried to open an attachment, and we block that file from actually reaching them. Hopefully that answers the question.
Thank you, Mark. So another question here. So I know that you mentioned tabletop models currently don't have with Intelligent AV. Do you have an idea of when those will be available for tabletop?
I do not, unfortunately. That would be a question for PM or product management and their timelines. I know that we are always constantly looking at improving our offerings that we have. And so there will be something down the line. I'm just not sure on what the timeline is.
Thank you, Mark. And so if we have a Firebox that is already retired, what model would you recommend for Intelligent AV going forward in the future?
And I see the question here. It looks like it's an XTM 330, and I think the recommended upgrade path from that is an M370 is right about the same. I know we have a sizing guide on our website. Perhaps we can get Christine to get the link for that after the webinar to help point you in the right direction. But we do have upgrade paths recommended on the website somewhere. I don't know off the top of my head.
Got it. Thank you. And another question here. So what about Skype or Video that are using proprietary HTTPS protocols?
Yeah, so I think this is a follow-up to that HTTPS and PIN certificate thing. With those, again, if we don't understand the protocol, the Firebox doesn't have a way to decrypt it, which means that shows why you really do need that layered security approach, because there are some cases where your network visibility, your network appliance just won't have visibility into a connection, whether it be a proprietary protocol or something that uses malformed protocols or PIN certificates. And that's really where the endpoint protection comes in as well.
Thank you. And can Intelligent AV help when connecting is made into TOR?
Tor. So this is one of those, the dark web browser, as they call it. The Firebox itself can't inspect Tor. We can block those connections if that's something you want. Most offices don't have legitimate uses for Tor. Obviously, some do. If you are trying to protect the anonymity of your employees. So if you aren't blocking Tor access, but you still want to protect against file downloads, that's really where endpoint protection comes in again to help keep your clients safe with that layered security approach.
Thank you, Mark, for that. And is there a file size limitation that
the scan file size on the Firebox itself is configurable. I can't remember what it defaults to. It's been a long time since I was in support, but I do know it is configurable, and then you can configure what actions to take for any file that violates that scan size limit, whether it be locking it, blocking it, or allowing it through if that's something you want to do. On the endpoint side, perhaps Sarah can chime in. I don't believe that Cylance has any issues with file size on that end.
Yeah, so the typical piece of malware is 1 to 5 megabytes. You could have something that's a little bit larger, maybe you tack on a little obfuscated data. Malware authors typically are trying to make it small and portable. They want it to move around quickly, especially if it's some sort of mutating and replicating worm. There may be a theoretical size limit on performance for analyzing a file and dissecting it, but we'd be looking at hundreds of megs, which you won't see a piece of malware. As far as something like an archive, you're going to unpack the archive first if you're on the endpoint. and then individually analyze the file. So it won't matter if you have a binary that's 5 megs or 50 megs. It's still going to pass through the model and get a score and be quarantined.
Perfect. Thank you.
All right. Thank you both. So that about wraps up our questions for today. Please note that if you want a link to this presentation, you can access it again using the same link you entered this. It'll have the recording on there. Plus, check out all the great resources we have available for you in the resource link widget. Has some great white papers in there from Cylance and also WatchGuard resources as well. And if see here, and if anybody is considering an upgrade to their WatchGuard device, definitely contact your local reseller or your sales team, the WatchGuard sales team. Be totally happy to set that up. Without further ado, I'm going to give you the 15 minutes back in your day. Thank you everyone so much for joining, and we'll see you next time. Thank you.